Mirrors and Lenses by Juan Camilo Jaramillo and Juan Ricardo Muñoz.
In point 12, we have a hubcap acting as a mirror, and due to its form and the fact that the man looks at both sides with r concave and convex, we can use formulas 1 over p plus 1 over q is equal to 2 over r for the concave, and 1 over p plus 1 over q is equal to minus 2 over r for the convex one, where q is the distance of the image, so that we can get the radius, which is 60 centimeters, and replace it in one of the previous formulas, so that we can get p, which is the distance of the face. In point 15, we will use a similar equation to the one seen in the previous point, but in this one we need to use the focal point, which is a half of the radius. Therefore, the formula is 1 over p plus 1 over q is equal to 1 over f, and the focal point is 16.1 centimeters. And also the magnification one, which is m equal to minus q over p is equal to 2, as the image is twice as big, and the result would be that q is equal to minus 2p. Therefore, we can replace q in the equation. So will be 16.1 is equal to p times x times minus 2p over p plus minus 2p. And we will get the distance, which is to 18 centimeters.
In point 17, gi is 3 times go, therefore go is negative. So gi is 3x and go is negative x. Then we can replace it in the mirror formula using focal point and get that x, distance of the object, is 8. Also, this image is virtual.
In point 38, we need to get the distance of the object, and we will use the magnification equation, which with 3 as the magnification. Therefore, we would use the formula m is equal to minus di over do, transform into ai over ao, which is 3, and also ai over ao is the same distance as di over f. Therefore, we can multiply f and m to get ai, which is 54, and replace it in the magnification formula with m as 3, and then get the distance of the object, that must be minus 18 centimeters.
In point 42, we have to use formula 1 over gi plus 1 over go equals to 1 over f, and rearrange it in order that we can get it di, which give us 3 centimeters, by replacing the values by the ones given at the problem. Then we do the same process with the other lengths, this time with negative numbers, and both are added negative 10, so that we can get f2, which is negative 11.1 centimeters. Also, to find the overall magnification of the system, we use magnification total formula, which will give us 2.5 as a result. Also, the image is a bright and virtual. In point 43, we use the mirror formula with the focal length to get q1, which is negative 8 centimeters, and then the magnification 1, which gave us the height of 1.08 centimeters, and also the distance of the image from the second lens, which was 7,47 centimeters in front of it. Also, we got that the image is bright and virtual.